Hello friends, so today I am going to take this lecture on phase diagram. So I will be discussing binary phase diagram. Binary means which contains two components. So we will be taking up a specific case of binary phase diagram where the two components, they are completely soluble in a liquid as well as in solid state. So this is how the binary phase diagram of these two components look like. So I will be taking a hypothetical case in which two components A or B, they are given treatment. So on x-axis we are plotting the composition and on y-axis we are going to plot the temperature. So at this point you can see it is pure B as there is no A. So as we move towards right on the x-axis, the composition of A in the alloy of A and B, it goes on increasing, and the composition of B, it goes on decreasing, till at the end point we have pure A and no B. So this is the binary phase diagram of two components completely soluble in liquid as well as in the solid state. So in this diagram you can see there are two lines. This top line is known as liquidus line because above this line we have only liquid phase, and this bottom line, it is known as solidus line because below this you have only one phase, that is solid. So you have liquid solution of A and B above this line and solid solution of A and B below this line, and between these two lines within this region you have both the phases present, liquid and solid. So this is how the phase diagram of this type of binary system looks like. Now let us discuss what are the phase changes that occur as we go on increasing or decreasing the temperature for a particular composition. So let us say at 40% A and 60% B, we are going to take this alloy. Now above this line the phase present is the liquid phase. So as you cool down the alloy, as you bring the temperature down, so up to this point, up to the liquidus line, both the components, they will exist as a liquid solution because both are completely soluble in liquid state. So at this point the solidification will start. So further decreasing the temperature will increase the amount of solid in the liquid. Means more and more solid solution will start forming at the cost of the liquid solution. So till you reach this point where 100% of the liquid solution is converted into the solid solution, and on further decreasing the temperature, the phase that will remain here, it will be solid phase. So this is how the changes take place for various compositions of alloys. Now in this case, from this phase diagram, we can have three different informations, important informations. First information is what is the phase present for a particular combination of composition and temperature. Second thing, at a particular point in the liquid phase and solid phase, what are their compositions? What is the composition of both the components in liquid phase as well as in the solid state? And the third information that you can gather from here, it is the percentage of both the phases. At a particular point, how much is the solid phase and how much is the liquid phase in terms of percentages. So these three informations you can get. So in order to explain these 3 points, let us consider this particular point that falls in the liquid plus solid region. So since this point, it is falling in between the liquidus and solidus line, so we can say the phase present in this case is a mixture of liquid and solid solution, mean both the phases that are present at this particular point. Now in order to find the compositions of liquid and solid state, what you have to do, just draw a horizontal line passing through this point, line parallel to x-axis. So wherever this line intersects the solidus line, so that particular point will give you the composition of solid state. So it means that the solid which is present at this point, it has this particular composition. Similarly, the liquid that is present at this point, you just extend this, and wherever it cuts the liquidus line, you just drop a perpendicular from there, and finally you can find the composition of both A and B in liquid state. So you have calculated or you have found the composition of A and B in solid state and in the liquid state. Now third case, how to find the percentages of solid and liquid. So for that we will be applying a lever rule. So in case of lever rule, we will take this point as fulcrum. So let us denote this point as O, and the point of intersection, the points of intersection with solidus and liquidus line, that we mark as A and B. So first we start with the percentage of solid state. How much is the solid present in the given solution? So since we are going to find the percentage of solid, what we have to take, we have to take this distance, that is distance of this fulcrum from the point which is intersecting the liquidus line. So remember this thing, we are going to find the percentage of the solid, but we have to take the distance on the liquidus line, means OA. So this distance OA divided by the total distance, that is AB. This is nothing but, this is the percentage of solid. So this much percent of solid is present. Same way for calculating the percentage of liquid, now you have to use the distance of solid, means percentage of liquid. We are calculating the percentage of liquid, but we are taking the point of intersection with the solid line. This is the main point you have to remember. So for calculating the percentage of solid, we have taken into the consideration the point of intersection with the liquidus line, and for calculating the percentage of liquid, you have to consider this point, which is the point of intersection with the solidus line. So percentage of liquid is OB divided by AB. So this is how you can find the percentage of solid as well as the liquid state. So I hope you must have understood the binary phase diagram of two components that are completely soluble in liquid and solid state, and how to find the percentages of both the phases and the compositions of the liquid as well as the solid state. So thank you for now.